In this video series, I work through a math problem or problems each video. Factoring a general polynomial is difficult. Though factoring quartic, or fourth degree, and cubic, or third degree polynomials are possible, the polynomials we are usually asked to factor are relatively simple to factor. Sometimes we need to use the formulas we looked at in the previous videos. A plus b squared is equal to a squared plus 2ab plus b squared. A minus b squared is equal to a squared minus 2ab plus b squared. Or a plus b multiplied by a minus b is equal to a squared minus b squared, but backwards. Right side to the left side of the equation. For other problems, we can factor out a common number, variable, or a common polynomial first. Let's take a look at the examples. We need to factor the following expressions completely. First, we have 16x plus 12y. The two terms here are 16x and 12y. If we look at the variables part, x and y, we can't really factor anything out. But if we look at the coefficients or the numbers part, 16 and 12, they have a factor of 4 in common. So if we factor 4 out from this expression, we get 4 multiplied by 4x plus 3y. Next, we need to factor a cubed, b to the 4th power, subtract 6, a squared, b cubed, plus 5, a to the 6th power, b to the 5th power. If we look at the number part of the three terms here, 1, minus 6, and 5, we can't really factor any numbers out from these three terms. But if we look at all three terms, they have some power of a and b. So we should be able to factor out some power of a and b out from each expression. So I'll just go ahead and write a and b here. If we look at just the a part of all three of these terms, we have a cubed, a squared, and a to the 6th power. The smallest exponent appears here, a squared, so that's what we should be able to factor out from all three terms. Next, if we take a look at the b and its exponents, b to the 4th power, b cubed, and b to the 5th power. The smallest exponent is 3, so we'll go ahead and factor b cubed out from this expression. Now that we know what we're going to factor out from each of the terms, let's see what we have left. First, we have a cubed and a squared. So that's a difference of 1. 3 minus 2 is 1. So we'll have just a left. Next, if we compare b to the 4th power to b cubed, once again, 4 is bigger than 3 by 1. So we'll just have b left. The next term is minus 6a squared b cubed. The number will remain, so we have minus 6. But a squared and a squared, b cubed and b cubed, they're the same. So everything here factors out. So we just have minus 6 left. And finally, for the third term, we have the number 5. And if we compare, first of all, the a's, a to the 6th power, and we factored out a squared, and 6 minus 2 is 4. So we have a power of 4 left. And if we take a look at the b's, we have b to the 5th power, but we factored out b cubed, so we'll have b squared left. And finally, we have 2ac plus ad plus 2bc plus bd. So if we try to do what we did earlier, ad and bd, these two terms don't have any numbers in front, which means we can treat it as if it has a factor of 1 each. And if we look at 2, 1, 2, and 1, we really can't factor any number out from this expression. If we take a look at the first term, it also has a and c, So let's see if we can factor a or c out from this all four terms. This term has an a, but this term doesn't have an a. So a can't be factored out from this entire expression. How about c? This term doesn't have c, so once again that doesn't work. So at first glance, it looks like we can't factor this expression, but let's try something. This is going to be something slightly different from what we've been doing for the compared to the first two expressions. We're going to break this up into two parts. First of all, we're going to take a look at the first two terms only, 2ac and ad. If we just compare these two terms, they have a in common. So let's go ahead and factor a out from just these two first terms. If we do that, we get a, and we'll be left with 2c plus d. Next, we're going to take a look at just the third and fourth terms. If we compare 2bc to bd, they have b in common. So let's go ahead and factor b out from the third and fourth terms. We'll be left with 2c plus d. Now, if we take a look at this new expression that we wrote, we see that this term and this term has 2c plus d in common. So we can factor that out from these two terms. And when we do, we see that we'll be left with a plus b, and we just go ahead and copy what we factored out, which is 2c plus d. So for some problems, we can't immediately factor something out from all the terms, so we have to group certain terms together and factor something out from just some of the terms first before we can complete the factorization.